Okay, welcome back. Mrs. Erickson here, Chemistry 11, talking about the start of 9.3 limited reactants and percentage yield. So today I'm just going to focus on limited reactants, and we're just going to stick with moles. Okay, so I'm going to show you a way to figure out in a chemical equation which of the two reactants is going to be a limited reactant. And I know that may not mean much to you right now. Yesterday we did an activity dealing with warrior mums, or at least I hope so, if I didn't go into labor yet. But I'm just going to quickly redo this. So let's just say I want to make a warrior mum. Okay, red mum, 2 black ribbons, white ribbon, and a really cool spear. And my question is, how many can be made? So start off with a mum and black ribbon, white ribbon, a spear. So I made one warrior mum. Let's see if I can make another. All right, I've made 2. Let's see if I can make a third. Oh, shoots, I'm out of black ribbons. So in this case, in this scenario, or an example, what is the limiting reactant? It would be the black ribbons. I ran out of black ribbons first before any of the other reactants. What's my excess is everything that's left behind. Okay, so the mum, the white ribbons, and the spears. So the limiting reactant is a reactant that limits the amount of the other reactants and the amount of product that can be formed in that chemical reaction. The excess is the reactant that's not used up completely in a reaction. So if I had 12 bottles and 10 bottle caps, which is excess, you would say, well, the bottles are. What's limiting? Well, bottle caps, because I ran out of them before the bottles. So the steps, 3 simple steps: choose one of the reactants in the problem, and then you're going to use the mole ratio of the 2 reactants to compute the amount of the other reactants, and then compare the amount with the amount available. So I know that didn't really make much sense, but I'm hoping after several examples here, it will. So let's just say that I'm looking at calcium hydroxide and how it's used to neutralize acidic spills, in this case hydrochloric acid. And my products are going to be calcium chloride and water. So I'm combining a base and an acid, and I'm making a salt and water. So they're saying, okay, let's say you spilled 6.3 moles of hydrochloric acid, and you put 2.8 moles of calcium hydroxide on it. Which substance, calcium hydroxide or hydrochloric acid, is the limiting reactant? So in this previous slide, I had 3 steps here. So step 1, choose a reactant. Let's just start with calcium hydroxide. So I want to start with calcium hydroxide. And what you want to do is convert calcium hydroxide basically to hydrochloric acid. You're comparing this reactant to this reactant. So you start with what you're given. They gave me 2.8 moles of calcium hydroxide, and I need to use the mole ratio to get to hydrochloric acid. So I'm in calcium hydroxide. That means my calcium hydroxide is going to go on the bottom. But what coefficient do I use? Well, you look at your chemical equation. There's nothing here, so it's going to be a 1. So 1 mole of calcium hydroxide is going to be on the bottom, and 2 moles of hydrochloric acid is going to be on top. So there's my mole ratio, 2 to 1. So 2.8 times 2 divided by 1 gives me 5.6 moles of hydrochloric acid. The final step is to compare the amount that you need, which is what you just figured out, to the amount that was given. So they gave me 6.3 moles of hydrochloric acid, and I needed 5.6 moles. So I have more hydrochloric acid than I needed. Therefore, hydrochloric acid is the excess reactant. Now let's just flip it. Let's take a look at hydrochloric acid. What if you chose hydrochloric acid as your first reactant? So first step is start with what you're given. Okay, I'm going to start with hydrochloric acid. They gave me 6.3 moles of hydrochloric acid. Your second step, use the mole ratio to convert hydrochloric acid to calcium hydroxide. So I'm in hydrochloric acid. That means hydrochloric acid is going to be on the bottom, and that coefficient is going to be 2, because this 2 represents 2 moles of hydrochloric acid. And I'm going to calcium hydroxide. There's nothing here, so that means 1. So 6.3 moles times 1 mole of calcium hydroxide divided by 2 moles of hydrochloric acid. HCl will cancel out, and I am given 3.15 moles of calcium hydroxide. So my third step, compare the amount with the given. So this is what I need. This is what I was given. So I'm given 2.8 moles of calcium hydroxide. I needed 3.15 moles of calcium hydroxide. Oh, I'm short. So calcium hydroxide is limited. So when you find the excess of one, the other one's going to be the limited one. Okay? Let's take a look at a different equation, looking at methanol, made by hydrogen and carbon monoxide. So if I have 500 moles of carbon monoxide and 750 moles of hydrogen gas, which one of these two is going to be my limiting reactant? So step one, choose a reactant. Okay, I'm going to choose CO. So start with what you're given. I'm given 500 moles of CO. Step two, you're going to use the mole ratio. So CO is going to be on the bottom. It's going to be 1 mole CO on the bottom. I'm going to hydrogen gas. It's going to be 2 moles on top. 500 times 2 divided by 1, 1,000 moles of hydrogen gas. Third step, calculate the amount that you need with the amount that you were given. So I was given 750 moles of hydrogen gas. I need 1,000 moles of hydrogen gas. Crap, I'm short. So hydrogen gas is my limiting reactant. All right, now this problem is a little bit different. If 500 moles of CO and 750 moles of hydrogen gas are present, how many moles of the excess reactant remain? So I've already determined my limiting reactant as hydrogen gas. And they just say, okay, use your excess to figure out how much remains unchanged, right? So first off, start with hydrogen gas and convert to CO. So 750 moles of hydrogen gas, convert it to CO by using the mole ratio. 2 mole on the bottom of H2, 1 mole of CO on top. Okay, and then 750 times 1 divided by 2 gives me 375. Now, this is my, yes, I was just making sure I did the math right there. Okay, so they give me 500 moles of CO. I only need 375 moles of CO. So therefore, CO is my excess reactant, right? So I'm given 500. I only needed 375. They want to know how much remains unchanged. How much is not used at all? So 500 minus 375 is 125. So you see what I did there? All I did was, on this slide, we started with CO to get to H2, and we compared H2 to each other, and we knew that hydrogen gas was limited. And here I just kind of flipped it, but then I added a question, how many moles of that excess reactant remains? So I hope that wasn't too confusing. All right. Let's say, same problem here, but they want to know how many moles of methanol, CH3OH, can be formed. Now, any question that asks how much can be formed, you want to use your limiting reactant always, because if you use your excess, you're going to be wrong. It's just like my warrior moms. Okay, you always start with start with your limiting. You can't create any more because your limiting is gone. So you just want to use your limiting reactant when questions ask you how much of the product can be formed. So always use your limiting reactant when they ask questions like that. So my limiting reactant in this scenario, do you guys remember? It was hydrogen gas. Okay, I was short hydrogen gas. So that's my limiting reactant. So all you have to do is convert hydrogen gas to methanol. Step one, start with what you're given. They gave me 750 moles of hydrogen gas. I'm going to use the mole ratio to get to CH3OH. So I look at the coefficient. I'm in H2. H2 is going to go on the bottom. 2 moles of H2 on the bottom to 1 mole of methanol on top. 750 moles of hydrogen gas times 1 divided by 2. 375 moles of methanol can be made from this scenario. Okay, now your book, this is the way that your book teaches you. So I went this route. I have never been taught this route. I'm going to show you method 2, and you can pick which method you prefer. This one, I don't know. I think it's a little bit more thorough, but it's up to you. yeah, so here we go. I'm going to get a pen here and do it on the board. Compare your product is for method 2. Now, method 2 doesn't work always. Method 2 is only going to work if you have one for sure product or you know the product that you are going to. Okay? So if you know the product that you are going to, or it tells you the product that wants to be made, then you can definitely use method 2. Otherwise, use method 1. So compare your products. So what you want to do is start with one reactant, all right? So I'm just going to start with CO, okay? So I have 500 moles of CO, and I want to get to methanol, because that's my product. So I set up my first conversion, my only conversion, I should say, in these examples, the mole ratio. So what's the mole ratio? All right, there's a 1 here, so it's going to be 1 mole of CO, okay? And then I'm going to methanol, 1 mole CH3OH. So I multiply across, I get 500 moles of CO. Oh, sorry, not CO. Ah! Well, that didn't work. Sorry. 500 moles of methanol, which is CH3OH. Okay, so that's for my first reactant. Okay, so now I'm going to do another stoichiometric equation using hydrogen, okay, and I'm going to go to methanol. So they give me 750 moles of hydrogen gas. I use the mole ratio, so there's a 2 here, so 2 mole H2 on the bottom. I'm going to methanol, 1 mole of CH3OH, and I multiply across 750 times 1 divided by 2, is it 375, right? Yeah. Moles of CH3OH. Now you're saying, okay, Mrs. Erickson, what are you trying to do here? Method 2 tells you 2 things. First off, the least amount of product you can make. Let me change my color here. Tells you your limit in reactants. So H2 is my limit in reactant, and CO is my excess reactant. And the second thing that method 2 tells you is how much you can actually make. So it's like you're actually knocking, you're what's the phrase that I'm thinking of that I'm blanking? Hitting 2 birds with 1 stone. Yeah, I think that's the phrase I want to say. So because I set it up this way, I have already figured out my limited and excess, as well as how much product can actually be made in this scenario. Okay, whereas here, or I should say, actually in any of them, but I'm just saying method 2, this is just another way you can figure out your limitant versus excess reactant. Okay, so you do have a worksheet. Make sure you check the due date on that one. I think if you have questions, just always contact me through Google Classroom. I remind you guys know the drill. I think I've been pretty good getting back to you on your questions. And yeah, good luck. And like I said, reach out if you're struggling. Take care.